Hey guys, welcome to another episode of TinkMakes. Today we are going to make some simple brackets, but first I guess I have to tell you why. Because right downstairs, Eugene and I just kind of renovated, not really renovated, but changed up the area downstairs where we film our Tink chats, skills, um, TinkMakes, all those videos, and kind of made it more soundproof. And so we also have a nuke at the bottom of our warehouse where we thought we would utilize the space and make it into a very soundproof area where we can actually do voiceovers in it, so that we have better sound for our future videos. So in order for us to completely kind of seal off the area on the side, I have to actually design some brackets, which is what I am going to do today. It's super simple brackets, which I thought I could do. Just don't have to, utilize Eugene, the master of designing, and that I can take care of. So today you'll be seeing me design these brackets. I'm not too sure right now to use Tinkercad or to use Onshape, because I don't remember how to use Onshape at all. I haven't touched it in a while. But Tinkercad would be easier, but I might decide to use Onshape later. But before that, we have to go take some measurements. So hey guys, I'm downstairs, and this is where we are making our new audio booth. As you can see right here, we padded it with foam and everything. And it's a great place to actually just do audio recording and with no echoes. And right here, I'm sure you see a glass. We're gonna put a panel right here, which will seal it off even more. Hopefully that gives us better sound audio. Eugene and I tested it out briefly with the panel there, and it does sound a lot better. So right now I just have to create some H brackets right here that will hold it in place so that even if someone accidentally hits the panel, it doesn't fall off and the glass breaks and everything. So there's H brackets I have to make here, and also another lower H bracket which I will have to make up here. I'll do some measurements right now, but first I'll move the panel over to give you guys a idea of what it actually looks like. Just give me 1 second. So this is what it's gonna look like afterwards. This door is very heavy, and there's glass right here, which is why we don't want it to fall over. So I'm just gonna take some measurements right now, and then come up with my brackets, and afterwards I'll either Onshape it out or Tinkercad it. Okay guys, so I just finished measuring and drew my designs and put in the measurements that I need. So next I have to do is, I guess, CAD it up. Before that, I'll show you guys kind of what my design looks like. Here there's an H bracket, a simple H bracket right here, and then here the under lower H bracket which clips on, both of them, and hopefully these design work. Okay, so now I took up my measurements and my designs, and now I'm looking at Onshape, and it's actually a bit intimidating right now because I actually don't remember anything at all. So I don't remember how to use it or even simply draw a line. The camera looks roughly the same as Tinkercad, so guessing if I press one to face, then I can get to plane that I want. And then I remember that you have to, on Onshape, you have to press sketch. So after it says select a sketch plane, I'll select it, and now it says sketch one, which allows me to sketch stuff. As you can see, there's different options that popped up. Right now I just need a simple line, and after I get the line, let's see. So I see it says length down here is inches. What I want is actually millimeters, so I need to change that, which is workplace units. Millimeters, that's
supposed to work now. Okay, now it says 81.653 millimeters. And now I need to dimension this line to be 77.04 times 2 plus 13.92. That's 168 millimeters. I need to change this to 168 millimeters, which I don't know how right now. So, okay. See, do I change it here? Oh, doesn't work. I think there must be something that is up here that allows me to change it. Not that's mirror, pattern, not dimensions. Now I have 168. Yeah, find out. I'm guessing in order to draw another line, I will need to sketch another line, I'm guessing. I need in between to be 32.70. Zoom in, I want to, yes, that's what I want. I want this to be 13.92. Now I want this point to be 77.04. This to this point to be 77.04. So this is what I need. I drew a line right here, and then now I'm going to draw this line here and then here. Next, I need to dimension this again. 168. And this to here, I need to dimension it to be 16.86 millimeters. And then I do the same on the other side. I'm sure there are shortcuts on how to make this faster, but I'm not very used to Onshape yet, so I will just have to do this the long way right now. 16.86. And then to here I need also. So it looks a bit messy, but I have all my calculations now. They're all done right. And now I need to turn it into a 3D object. Extrude. I'm just gonna say roughly 100. Now I have my object. Simple H bracket. Yeah, I think I may be done my first part. I may need Eugene to just check my dimensions and tolerances. This is just gonna wedge on for now, I guess. Not too sure that I did it right, but everything should be correct. How do I export? Must be an export button somewhere. Should export. And format, I want it as a STL. Millimeters. Cool. So now that I have my file, I am going to switch to tinkerine.com/tinkerine-cloud. I'm already logged in, so I get access to my Tinkerine cloud once I press this. Now I drag in my H bracket, double click it, and it will get imported in here. So this is going to be my object. And then as we can see here that there's going to be an overhang right here, so I'm wondering if I can actually just put it down like that. Okay, so it seems to work. Since this is supposed to be holding up a very, very heavy panel, I'll probably have to print this in dense. Low is fine, but dense, make sure that structure integrity is fine. And after that, I can start slicing. But before that, I probably should ask Eugene whether or not I did this correctly. So here I am. Hey Eugene, you want to check this? I think I did everything right on Onshape and everything.
Okay, sure.
Yeah. Well, during pandemic, so we gotta mask up. So Onshape right here, design an H. I wanted to create these nubbins, but I thought that was too complicated, so I stopped.
What do you mean nubbins?
So you know our panels, there's a glass there, right?
Oh.
I wanted to go click onto it, but
needed.
I don't know how to do it. But you said not needed, so I guess it's fine.
Yeah. Okay, go to the sketch.
Edit, sketch. As you can see, according to my measurements, this is 77.04. This piece is going to be 13.92. That's gap. So if you add all these together, it's 168. So this whole line is 168. 168. Correct, right? And then this line from here is 77.04 distance, millimeter wise.
Okay.
In between is 13.92. Bottom is 77.04 as well.
Why did you dimension that twice, the same thing?
Well,
Right.
well, I didn't know if the second line that I drew was.
Sure. I just lean over. I mean, that's fine. Doesn't really matter for
So
dimension.
this dimension is for this. This is for this.
Oh, I see. I mean, the only thing I would probably say is you need some tolerances, man.
Yeah, that's what I was thinking
So,
before
like,
I
if
was
it's
doing
20
it.
If it's 32.7 and the thing is 32.7,
Yeah.
it's not gonna fit.
Is it not gonna wedge fit?
No, it'll be slightly under dimension. Just because of the way that the FDM technology works.
Yeah.
So like you probably want like
20 meters, like
you probably want to add
our
about 0.3 millimeters to that. 0.3, 0.4.
0.3. So
it's a slip-on fit because you don't want this thing to crack, right? You want this thing to hold.
yeah.
So that's the only thing. Like this dimension is the only thing that I would give it a tolerance.
So I should do it 33.
What was it before? 30.
32.7.
33 is fine. absolutely fine.
Okay.
Yeah. So go out of the sketch. The only thing that I would probably do, you know how the first layer of a print usually
Yeah.
flares out a little bit?
Yeah.
So you can combat that by just chamfering.
How do I use this tool?
Alright, click that.
I know we have a tutorial of this and I should know it, but
So click it.
click it.
So click the face you want to chamfer. So click that, you'll see it. It'll give you a. So instead of 5 millimeters, change it to 0.5. Enter. Okay. You see that little lip?
Yeah.
Okay, now do it to the other side as well. You can actually just double click that. Can you double click it? I don't know how long chamfer works. Right click maybe? Edit.
Yeah. Edit.
And then add that face to it too. Yeah, there you go.
Okay.
So now when it prints,
Yeah.
when it flares out on the bottom a little bit, the chamfer will catch it,
Yeah.
and so it'll come out straight.
Okay.
Just like it's a FDM design hack, I guess.
That's a neat thing to know.
Yeah, I mean, that's good. We'll probably just end up with it wedged on, and
Yeah.
it will work perfectly fine.
I'm guessing we probably need a couple of these, like 3,
2 is probably enough.
2.
Yeah, we can always add a little bit of double-sided tape in there,
Okay.
right? Like
Well.
a little bit of double-sided
Mhm.
tape, like so rotate it.
Yeah.
Like on this face and that face.
Just stick it to
Yeah.
the thing. Okay, well, this concludes the first piece, and I just got to print it, and then I'll just have to design the second one.
Yeah, I'm just looking
Yeah.
at this. I would probably suggest doing something above that corner.
Yeah. I had something in mind already.
Alright, cool.
So now I have to export my new one out again. After I export it out, in my library there's the old one, so I'm going to delete that one. I'm going to go back and edit some settings. Low, 2 walls,
Okay, 3 walls.
3 walls according to Eugene. Print at 120 millimeters per second because that's how fast I can print with Ditto Pro R. Slice again. So I actually reduced it by 7 hours just by printing it faster. And now I can save the file and bring it over to the printer.